this video I wanted to provide your first introduction to the unified modeling language, and we're going to look at a subset of the entire specification, a design artifact called the class diagram. There are many different types of diagrams and artifacts or things you produce when you use the unified modeling language within an application's lifecycle, the full development lifecycle of an application. The class diagram helps to illustrate the particular attributes and methods of a given class, as well as the relationships between classes within your application. Now, there are two ways to go about using class diagrams and UML in general. You can be very formal about it and even allow your diagrams to drive the development process. Some tools, really expensive tools like rational rows or less expensive tools like Visio, can develop kind of full-featured diagrams from different perspectives. There's another train of thought, however, that says all of that design really is unnecessary, that code is the ultimate expression of what a system should do. And so they look at UML as a method of explaining the approach or design intent to a series of coworkers who are standing at a whiteboard or just sketching out some ideas about how to design in your classes so that they'll interact on a napkin. And so that's the approach that we're going to take on LearnVisualStudio.net. Keep in mind that there's a much more formal approach. We're just not going to go that route. Quite frankly, I'm just not a big believer in it, having seen it in use. Other people are adamant believers in it, and you know, if that works for your organization and the personnel on your project, awesome, more power to you. Okay, we're just not going to do that here. So you can see here that first of all, I have just a blank surface, and what I want to start off with is the class diagram basics, showing that a class is represented usually as a rectangle, and the rectangle typically has three compartments. In the three compartments, you'll put at the very top the class name. So in this particular case, you can see that we have a class called auto. Now, this class is going to be similar to the auto class that we created within the examples from earlier today. So the second compartment is where you would put your properties and fields, and then the third compartment is where you would list the methods that make up or comprise your class. So in this particular case, we can see that we have a private field that's of type string called make, and notice that the minus sign is a way of denoting that it's a private as opposed to a public member. Notice that you have the name of the member itself, lowercase m make, and then the type that's referenced by a colon. All right, so we also had speed, which is of type integer. Again, it is a private field. And then we had a public property called maker, which is of type string. Public because notice that there's a plus sign, and also by our own notation we have a capital M in maker. And then we also define current speed. Now in our application we had a lot more items defined, but in this particular case I don't want to represent all of them, so what I do is just use an ellipsis that should signal to whoever's looking at this class that there might be more, but they're just not pertinent for the purpose of illustration or discussion for my current little diagram here. Okay, so you can include and exclude any number of items. Just include the ones that make the most sense for the design intent that you're trying to express. They don't have to be a complete full representation of a given class. It can just be a partial representation. Anything that's pertinent to the current discussion or line of thinking, okay? So here in the methods compartment, we see we have a public, again with the plus sign, method called accelerate. Notice that it defines a parameter of type integer, so between the parentheses we've defined a single parameter. If we had multiples, we would just separate them by a comma. And then it returns, at the very end you see another colon int, and that means that the accelerate method returns an integer. Okay, easy enough, right? Here we have our private helper method that we created in a previous video called WriteLine. WriteLine was void, so it returns nothing after the parentheses. It also, I don't believe it accepted, maybe it did accept something and we just didn't represent it here. But if you had no methods, just let's assume for a moment that we had no methods we're passing into WriteLine, then you would have an empty set of parentheses. That's what I was trying to illustrate. Okay, so that is a more formal way to define a single class. You know, you can decide how many items you want to include. Clearly, this isn't the full definition. I could make the full definition and then hand this to somebody and then expect them to go off and be able to build it. That's just not the case in my particular choice of items to represent here in the diagram. So let's start over again now and talk about another way to represent with even less information, but that seeks to define a little bit more about the relationships between certain classes. So if you'll recall, we had an auto class that had a relationship with an engine class, right? And the relationship can be noted with just a single line, and typically you're going to use an arrow at the end of that line to denote the direction of the relationship. So an auto has a engine, for example. It is the one that is going to hold a reference to the other object. Auto holds a reference to engine. And typically what you do is, or what you can choose to do, is add the name of that reference. In our case, it was a public field, so it was capital E engine. Now, what we could probably do is what we talked about earlier. We can encapsulate that and use a lowercase e engine and make a private engine, and then create a property to do the getter and setter on that private engine, right? So, but in this case, I just left it as public. And then you can also denote the number of instances that are held by the relationship. So in this case, an auto will hold one reference to an engine and will reference that engine using the engine field of our application or of our class, right? So that's all we're trying to do, is establish the relationship between two classes. All right, so let's move on. Let's take another set of classes here. Remember the relationship between auto and auto customer. We said that that was a composite relationship, whereas before, in the previous example, we had an aggregated relationship. In C#, it has a little bit more meaning than in UML. Some will suggest that you don't even need to make a differentiation between aggregation and composition as far as UML is concerned. However, if you really want to be a stickler for the notation, this is how you would represent a composite relationship, with a little diamond at the beginning of that line that represents the auto owns a or has a auto customer. Okay, so that is how we would represent a composite relationship. Okay, so armed with that information, we have our first steps towards understanding how to explain ourselves to others on a whiteboard or a napkin, or even using a formal tool, our design intent, how we want our classes to be structured and how we want them to interact without having to write any code whatsoever. Okay, and so in the next exercise, what I hope to do is to give you a diagram, and then I want you to go in and attempt to build that diagram in code. All right, so that's why I wanted to bring this up now. And it's good because as you start reading books, especially about object-oriented development, or you see websites, they're going to represent relationships between classes in this shorthand manner using a diagram, because visually it helps you understand the relationships more so than having to parse through tens, hundreds lines of code in order to really understand what is being expressed. Okay, so that's about it for class diagrams and the unified modeling language for now. We're going to continue to build on the UML in the next tomorrow, and maybe even the day after that. But ultimately, we'll want to create an entire workshop just to talk about UML and explain a little bit more about the thought process behind when you would use it and when you would steer clear. So we'll talk about that later. That's it for now. Thank you. We'll see you in the next video.